This one? My other class asked about that one too, so get that out of there. Okay, 15, we've got a function, find the x value where the average rate of change equals the instantaneous rate of change. So, I guess you don't have to know this, but they're referring to mean value theorem. It doesn't do you any benefit here, except it might give you some comfort that you've practiced it a bunch of times. So, instantaneous rate of change is going to be derivative. So, if I take the derivative of this, I would get 1 over x squared times 2x because of chain rule. This x squared is trapped inside of the natural log. And then when you reduce that, it's like 2 over x. So there's instantaneous rate of change. And we're supposed to figure out where it equals the average rate of change. So average rate of change, if you have the function, is like the slope formula. So do f of e minus f of 1 over e minus 1. I'm just doing this down here, so it's not as scrunched. So if I plug in e, you might want to think of this, you might want to bring this 2 down to simplify it from log properties. But then if you plug in 2, you get 2 times the natural log of e, which would be 2 times 1, minus 2 times the natural log of 1, which would be 0, over e minus 1. So from the slope formula, it looks like the average rate of change was 2 over e minus 1. And now we just need to solve our equation for x. So we can multiply both sides by x, multiply both sides by e minus 1, and divide both sides by 2. And you should end up with that. So there's 3 considered big theorems that kind of get grouped together in calculus. Mean value theorem is going to be on your AP test, multiple questions. Being ready to do instantaneous rate of change equals average rate of change is definitely to your benefit. Extreme value theorem is also pretty good. That's where we use it. We use it mostly on free responses and candidates test, but that will be on your AP exam as well. Probably the least important of the 3 is the intermediate value theorem, but it often does show up also. So, but mean value theorem is a big deal. So, is there anything specific here? No? Okay, was anybody else going to ask about 15? Need to ask while it's still up. Okay, I saw somebody else's hand. Was it Harper?
I also was going to ask about 15.
Oh, you were also going to ask about 15. Okay. I would say one thing that would make this harder, that's not obvious, but when you're doing this part of number 15, f of e, sure, you can plug in e here, and natural log of e squared just doesn't sound nice. It doesn't simplify nice. So, you know, no one's telling you to bring that 2 down, but notice when I did, it just made the numbers come out nicely. But I could see why you might not do that at first. So, okay, somebody else have another one? I'll try to give everybody a chance to ask one before I ask for duplicates from people. Anybody else have 1 or 2 I can help with?
You do
13. Is it this one? But 13 is definitely my least favorite because it's the longest one by far. Okay, so 13 says find average rate of change of g of x from 1 to e, but they give us the second derivative and a point on the first derivative. So that's a little bit different information. So I know I could find the average if I do 1 over b minus a. This is like dividing by the total distance times the integral a to b of the derivative. But I don't have the derivative. But I know that's one way to find average rate of change. But they really give you enough information here to find the first derivative. because we can integrate the second derivative to get the first derivative plus c, and then this allows us to solve for c. And then once we know what the first derivative is, we can plug that in here, where 1 is a and b is e, and then that's kind of the approach we need to take. But you gotta know what your options are when it says average rate of change for this question. If you don't know that you could do that with the derivative, then you're probably not going to know how to move forward. So if I integrate this guy, raise the power by 1, divide by the new power, this would be what the derivative looks like with the c in it. If you plug in 0 for x, I'm sorry, a 2 in for x and a 0 in for y into this, you would solve to get that c is a half. So the full derivative, full first derivative would be this. So now I have all that I need. It's just a matter of working all the arithmetic out. So again, this is what the formula usually looks like, but this is really just telling you to divide by the distance traveled. Divide by the difference between e and 1. I would say sometimes you guys don't keep up with this, and then you hope that you remembered at the end, and that doesn't always pan out for you. So I would be careful with that. Here's the derivative, and I want to know from 1 to e. So to give myself more space here, I'm just going to focus on this now. So I've got this. Integrating this is not too bad because that's just a natural log of absolute value of x, but negative. This, I could just throw an x on it, and I'm already done with the antiderivative. I would say that I guess one challenge to this question, if you're anything like me, I kind of ran out of space in the question. So sometimes I don't want to give you more space because it's kind of gives you a hint that the question is going to be a longer process. So I kind of ran out of space here, but of course you can always do it on a separate sheet of paper. But if I plug in e into this, I get -1 plus 1/2 e. If I plug 1 into this, I get 0 plus 1/2. I could combine these. -1 minus 1/2 would be -1.5 or -3/2. And I've got a 1/2 e and a -0, but the -0 doesn't do anything. Yep, still looks good. Then to try to figure out which one of the answers looks the same, I went ahead and distributed this. Oh, sorry, this is 1/2 e, so that puts it in the numerator. After distributing, they have the same denominator. Well, I guess they had the same denominator there as well. So you could push those together. Okay, and then finally the last step. This is I think this is a good step to make you do. I don't know if this was the best question for it because it was such a long question in general. But this still doesn't look like any of the answer choices because they did an algebra trick called factoring out the negative. So they factored out a negative out of the top and the bottom. And then you can let the negatives cancel, and that basically switches the signs of the stuff inside. So 3 over e over a 2 minus a 2e was one of the choices. So several different things to worry about here. The factoring a negative out, again, it's not a common algebra trick, but I would hate for you to miss a multiple choice question on your AP exam. simply because you didn't know how to make your answer look a little bit different. So that's good to learn from. Again, I know this is kind of intimidating that there's so many steps, but I basically just plugged in E, plugged in 1, and did a bunch of arithmetic from here to here. But the most important part of this question by far was knowing how to set it up to get the answer you wanted. Because you're not going to do all of that unless you know it's going to work. This is not the only way to find average rate of change, but if you have derivative, it is one way to do that. So that's what you got to remember. Now, if you have a function, you can do something different, but if you've got the first derivative, that's what you should do. Okay, is there any parts of that in particular you'd like to ask about? Okay, all right, somebody else who hasn't asked one, have another? Okay, anybody who did ask one, have another question or two? Okay, well, hopefully you guys are asking what you need to ask, but just in case you're not, which I hope you are, but my third period asked about 5, 8, 12, 13, 15, and 16. So I did post those up as videos on the class website yesterday afternoon. So I guess if you need help on those, but you didn't ask about them for right now for some reason, there's at least that little bit of help still there. Okay. So again, the next part of the homework is going to ask you to do 2 FRQs. And again, once you're done with the whole thing, we can kind of talk about cut score and all that kind of stuff. But most students tend to think that the FRQs points are harder to come by than the multiple choice questions. Of course, multiple choice, sometimes you may have no idea and you can still get lucky and guess. That's not usually the case with free responses. So we will continue to try to make free responses a priority so that those hopefully get a little bit easier to you. So I don't know where I was going with that, but I do want to go ahead and do this one practice FRQ today. So this is from 2017 FRQ 5. FRQ 5 is always going to be a no calculator. It's only the first 2 that are calculator. The last 4 are no calculator. And I think the average was pretty decent. It's like 3 point something.
It was 3.59.
Yeah, 3.59. And I did this one Friday, and I got 8 of the 9. So I will tell you what careless mistake I made, but you need to see if you make the same mistake since this one has the no, it's just for practice. So, all right, so go ahead and start, please, and I'll tell you when 15 minutes is up. And again, as we do these, you guys should be trying to get an extra point or 2 occasionally, because the question types, the calculator skills, those things should start to become a little more repetitive. time's up. Okay, so let's check out the scoring here. And again, you do need different colored pen for your corrections, additions. So come borrow one if you need to. So this one was pretty evenly split up. A lot of times FRQs have one part that's worth a lot more, but I think all these are just worth 2 or 3 points. So for part A, you should have tried to take the derivative of position of P, and if you did that correctly, you ended up with this or this. These are the same thing. So if you have that down, that you thought about that and did it correctly, you get a point. Now, if you don't have that numerator, you forgot chain rule. You didn't take the derivative of the inside. Bless you. And of course, I guess to know when it's moving to the left, you have to remember that that's when velocity is negative, and the way you find velocity is by taking the derivative of position. So that's why they did that. Okay, and then one answer for the interval, which was 0 to 1. So in part A, if you figured out he was moving to the left from 0 to 1, you get the second point. Okay, any scoring questions you want to ask about A? Yeah.
The 0 is less than or equal to t is less than or equal to 1. Does that still count?
You said 0 is less than or equal to t is...
Less than or equal to.
Yeah, that's fine. On intervals, honestly, I would prefer if you just use parentheses all the time. Sometimes they use parentheses and sometimes they use brackets, but that's heavily disputed in the math community anyway. Just always use parentheses for intervals. If you're talking about domain or range or something, it makes a big difference, but for intervals, I just always use parentheses. That will always be considered correct. Any other questions about A? Okay, part B could definitely be a very challenging part. You can see in their work that they made a little line chart to help them keep up with when it's going to the right versus left, right, left, right. Notice how they have them labeled. They kept their information nice and organized. And if you didn't keep your information nice and organized, it's going to get more challenging here. But looks like 1 point came from the intervals, so you had to get, they're going in the same direction from 1 to 3 and 5 to 8. Again, if you're doing this in your head and you're not putting down pencil to paper to organize your thoughts like they did, you're making the question way harder than needs to be. Notice 1 to 3, they're both going to the right. 5 to 8, they're both going to the right. That's why that's the 2 times they were going in the same direction. Even if you don't think you need to put it on paper for the justification point or anything like that, you still want to organize your thoughts. Okay, and then they gave a second point if you did this analysis using the velocity. So if you tried to think about when they were going the same direction based on the velocity of P and the velocity of Q, then you get that point. So even if your intervals were wrong, if you showed that you knew it had something to do with velocity, they would give you the second point. So that's a pretty friendly point. You want to know when something's going to the left, you're trying to figure out when his velocity is negative. You want to know when it's going to the right, you're trying to figure out when the velocity is positive. Now notice there are a couple other things here. If you did not use the velocity and somehow you accidentally got the intervals correct, you get 0 points. They're not letting you have either one of those if you don't refer to velocity.
You mentioned velocity in your answer. 0.
What did you say about velocity in your answer?
I didn't say anything about it. I said both travel to the right from 1 to 3, 5 to 8.
Okay.
Based off what I've done in the
that would get you the first point, not the second point, because you're not saying why. Unless you showed why you thought that. But again, it doesn't even have to be this. You don't have to do a line chart. It's just that this line chart organizes the information greatly. Notice you also will get 1 point if you got one of the two intervals, but you also showed that you tried to use the velocity on both parts. So if you just did something wrong, got one interval right, but the other interval wrong, they gave you one of the 2 points. Yeah.
I got both intervals wrong, but the analysis right, so good point.
Yep, you still get the second point. If you use the velocity to try to figure that out, then they still give you the second point.
Hey, if you analyze the chart of the velocity of t and velocity of q multiplied together, would that work? Would that count for the point? One positive, one negative, and both if both are the same sign, then
It
multiply
very
together.
much could, but it probably depends on how detailed your explanation is. If you just multiplied them and then said, here's my answer with no like reasoning, like no explanation to why you did that or why you thought that would work, what you started to say, my guess would be you probably didn't explain that on your paper, which is probably why you wouldn't get the point. But if you wrote that on your paper, this is why I multiplied them, then I think you would. Or I know you would, that would be fine. Okay, moving along here, part C had 2 more points. So they asked you for the acceleration of q at time 2. So if you got that correct, it was -4 or anything equivalent to -4. So you could have stopped back here. 2 times 2 minus 8 is also the same thing as -4. You get 1 point. So you have to remember the derivative of velocity gives you acceleration. Then they asked you if it was speeding up or slowing down, and you should have said the speed, it was slowing down, the speed was decreasing, but you also had to have the reason. It's decreasing because velocity and acceleration have different signs. Acceleration at 2 was negative, velocity at 2 was positive. It was moving to the right, but the acceleration was increasing the rate of speed towards the left. So that's decreasing in speed. That one should be pretty easy for you with that mini quiz we did the other day. You just got to make sure they have the same signs to be speeding up. Okay, on to part D, and this is where I made a mistake, although it wasn't a big mistake, but this one had 3 points. So they give you 1 point if you did the antiderivative correctly. So if you integrated the velocity of q, so you did the antiderivative of t squared correctly, minus 8t correctly, and 15 correctly, you got that point. You had to use the initial condition for a point, so that would be 5. Remember, the integral just tells you how it changes over time, but if you want to know where something is, you also have to know where it starts. It doesn't help to know that a car traveled 10 miles. You don't know where it ends up unless you know where it started. So, starting value plus integrate gives you the change. So, if you put that, showed that you calculated that 5 in your work, you got that point. Easy point, but you guys overlook that occasionally. I would say you're a lot less likely to overlook that if you're using your time at the end. Unless you just ran out of time, you totally could have gone back and caught that before you quit. All right, and then 1 point for the answer, which could be 23, or anything, any arithmetic that's also equal to 23. So you could have also stopped back here and not risked it. Yeah.
So I guess if I forgot the initial condition, but my arithmetic was correct, and I got an answer, would I get the third point or not?
You got 23 correct?
I did not get 23 correct, but I got the answer correct based on like what I did.
So yours was 5 less than that?
Yes, I got 18.
That's tough. I think that most of the time they would give it to you, but they've never come out and said that they would, so I can't promise that.
Okay.
They try not to penalize you more than once, so that's why I think you would probably get it, but I couldn't guarantee it. So, all right, so in all of this, my mistake, and I was actually being pretty cautious of this, but it gives you some input on if you made the same mistake. I knew that in these question types, I've seen these question types before, they like to do these where there's 2 different ones. We had particle P and particle Q. Everything I did was great. But then right down here at the end, so you can learn from my mistake, I, for just a split second, looked at particle P instead of particle Q, so I thought it was changing directions at t equals 1, because that's where particle P changes directions. And I just was not careful about which one it was talking about, and so I ended up losing one of the points for that reason. So, especially when there's two different ones, P and Q, if you want velocity of P, make sure you're taking the derivative of position of P. If you want the acceleration of Q, make sure you're doing the derivative of the velocity of Q. You got to be careful with those points. And I know my work's not up here, but you need to kind of make a habit out of it the same way that they did. Like this. Like if you're talking about P, the position of P, call it x of P. If you're talking about the velocity of Q, do V sub Q. And then this P and this Q help you remember which one you're talking about. Keep those straight. So I think those of you that take physics have to do a lot more of that subscript type stuff, so that's not as hard for y'all. But okay, do y'all have any comments, suggestions, grading questions? Yep.
You said you used particle P
Uh-huh.
on D instead of Q. I also did that. How did you get any points using that? Did you still use Q as the?
I still use Q, so I still did the antiderivative correctly. I still used the initial condition, but instead of going from 0 to 1, I think, or 0 to 3, I think I went 0 to 1, so that threw off my final answer.
Yeah, I used the Q equation, like integral of Q. I mean, the P equation.
Yeah. And I remember you guys are the class that you guys still have one more FRQ to do in the 2022 packet. Is that correct? Okay. I'm still going to try to give you time to do the last one, but the last one is similar to this one in that there's two different points, a P and a Q, and you're worried about acceleration and velocity and all that kind of stuff. It's very similar to this one, so maybe this will help when we get to that one. So go ahead and write up out of 9, mostly for your information there. Again, great if you got above average, fine if you didn't, but try to find a point or two that you can get next time. As long as you continually do 1 or 2 points better when you see an FRQ type for the second time, you'll be in good shape. Okay, and I'll probably ask for that in a class or two, so make sure you have that numbered as 127 and put away somewhere nice in your binder. All right, next up, we're going to look at a couple of the mock exam questions, and to be honest, I didn't have time to look up the analytics to your class, but I'm guessing that they're probably pretty similar to my 3rd period class. So I will have to pause the class recording here because this is considered a secure exam. I couldn't make you a hard copy on paper of this exam and let you take it home. We can use it in class. AP Classroom, they guard it to some degree, but we can't take this stuff outside of class. But I picked out a few questions that I think with a little bit of review you guys will be able to get next time, but also questions that most people missed. If only 2 people missed question 1, it's not the best use of our time to go over question 1. So I'm focused just on stuff. Give you a little bit of time for you to look at some of your other questions. So honestly, what I would probably do, your AP Classroom, it doesn't show how other students did, does it? No? Okay, what I would probably do if I was you is just go to question 1. If question 1, if you guessed the answer right, or if you missed it, most people got question 1 right. So that means that it's probably something small to correct, but I would try to learn from that mistake. Then look at question 2, then look at question 3. Those were not as good, but I think that you can still get those. Actually, one of the best, the 6th best question was actually number 4. And number 4 was U substitution, which is usually one of the hardest concepts. So, how you guys did that good on U substitution and then bombed the slope field, I don't know, but this is why it's good to learn from these mistakes on a practice and not on the real thing. So, okay, so you guys have got 10 plus 15, so you've got almost 25 minutes that you can try to find a few questions to learn from, and I'll be happy to come around and help. Remember, we're going to go over more of these questions, but again, we'll probably never go over question 1. We may never go over question 3. We may never go over question 4. It just depends on how much time we have, how many people missed it, and how much work I think it's going to be. Like the very, very last question is one that you guys is not worth your time. Derivative of inverse functions is not something that we teach anymore. It just rarely shows up on the AP exam. So that one, it's great if you can do it, but to learn how to do that one would probably take you 60 minutes to do it and practice it. There's other ones that are far more efficient that you can focus on. Okay, so go ahead and start there, and in a few minutes I'll come around and try to help you out a little bit. Yep. I don't remember the exact cutoff score, but I think you need around 45 points total to get a 3, but that's multiple choice and free response. So if you can imagine, if you can find 10 more multiple choice between now and the AP exam, that's 12 more points. That's over a quarter of the total points you need just to even pass. And 10 questions is not that much with how much time you guys have to study. Not just today, but I mean between now and the AP exam. Also, I really encourage you guys to look at the same questions in your table groups. If you all want to look at question 10 together, maybe they could help you out with one and you could help them out with another one. Also, I do have actually 2 more mock exams I can assign to you on AP Classroom, so I will do that. Those will be completely optional, but if you feel like you want to study and practice some more and then try a different one, that will be an option to you. I just don't want to open it up in Google in AP Classroom right now because I don't want it to confuse you with your homework. So. Also, if you scroll down, AP Classroom, I don't know if y'all are familiar with this, you probably are. If you scroll down on a question, it'll tell you why your answer was right or why your answer was wrong. Sometimes that's enough to help.
Also, last weekend was kind of a blur. I did a lot of not my own stuff. I did like an hour and a half of calculus. And then I did like
Well, it's good to know that.
3 hours of chemistry. Actually, no, I did like 3 hours. It was more than 3 hours because I also studied.
You know, like a desk going up or something?
I'm waiting for the mock AP exams. Chemistry.
On Sunday?
On Sunday.
What weekend desk?
Schedule.
So sorry.
It wasn't that bad.
I'm so sorry.
I got to leave half an hour early.
I'm so sorry.
It wasn't that bad. And I'm glad I did it because I feel, before I was fairly confident that I would at least get a 3 hour class in maybe. Now I feel maybe
This one's-
if you can
Okay, so
apply.
this is like from 1 to B, that's your X, like how far.
I have a test tomorrow morning. I
And
keep
so
in a class,
this
but I don't have till noon.
shows your width. This says the width is 2, since it's that issue, so
I mean,
it
it
says from 1 to
has
B is
to
2, and then 2. So B equals.
You did? I don't know when I'm gonna be there tomorrow morning. Oh, wait, no. It's during the Atlas testing.
Because
I have a English test during the Atlas testing.
Oh, yeah, that's.
That sounds kinda-
That one's easy, so
That sounds like a-
But we are continuing a different part of the same exam.
the interval is 3 to 1.
I'm going to be
So
in
it's
the
asking,
exam for so
what is it
long.
asking? I'm not on.
Yeah, I had to finish, I have to do the application for 9 chemistry tests today. So, you know,
Work
chemistry.
use?
Find the number.
Does that work use in chemistry?
Yeah. The MCQs are just like, you know,
30.
does this factor have,
Well, I'm starting at 1.
The other ones are also that, but you have to actually write it down.
Is that what it
Okay, so the first one is really just.
Oh, and there's also math, lots of math.
It's just, I think
That's
it's
fun.
really just about like.
It's not hard math.
Yeah.
Ironically, I usually do better on the FIQs.
And like, yeah.
How? I don't know.
It probably makes the question slightly easier, but you have to remember it.
Or maybe you just write down the class makes me
Idea, cover up the answers and then try to figure it out and then answer it.
I usually don't look at the answers until I come to my own decision. I think it really is great at the answers, like except for the ones that you actually have to look at the answers. Because really the answer is 20,000 just, well, that's not really doing anything for you, it's just wasting time.
Yeah. Also, I have somehow regained my ability to be good at testing.
Hooray. I lost it except for that one time that I lost it in chemistry and just kind of stared at the pages for 5 minutes and then had to rush to the end and still somehow managed to get a maybe 7. That's
Impressive.
pretty good.
Oh, 16.
I really don't know how I managed it, but.
I used to be really good at testing, and then I suddenly wasn't as good at testing, and now I'm good at testing again. Because I had a history test yesterday that I didn't study for, didn't know any of the answers to, but after reading the paragraph, I was fairly confident that I got the highest grade in the class. Because I felt confident about like 90% of the answers I gave, and the thing is, the highest score in the test last time was a 72% out of every.
Even 80 or are you,
AP roll. It was out of every single class we had, the highest was a 72%.
Yeah, get busy, we got a lot to do.
you need to be logic out quite a bit.
Yeah. Well, future questions, hopefully have future questions. Sometimes I put the answer to previous questions in the statement of future motivation.
Yeah.
Or that once you use the future question, I have later question to previous question, and those are the ones that gives the previous question. If there's like one thing that.
Well, you just split this fraction up, you know, the x squared over x minus x over x. So this just becomes x, and that becomes minus 1. Then that should be something to agree about.
That's probably not how that's meant to be done, but it works.
The explanation has to be about like limits when x is, I didn't know.
Do you think you can actually like remove this stuff?
I just watched you do it not long ago, and I think I knew before I knew what it was.
Yeah, I would just, yeah, that's all I would do. Split apart your fraction. And then it can integrate by hand. Okay, I'm just kind of wandering around, but if y'all have something I can maybe help with, raise your hands and I'll come over. So this was a calculator question. Okay, so this is kind of like, the last part of that practice FRC that we did. You have starting value, -7, let's put that in. And plus, now the integration will tell you how it changes. So if you integrate this, well, where do you want it to stop? Okay, so that's the top one. Okay, and why do you pick 2 and not 0?
We've seen it already.
Yeah, so you knew the value of 2, so you need to know how does it change from 2. Now, if you type that in, it should give you a decimal answer, but.
I feel like it's this to the point where I don't hate it.
So where you start at,
And then,
plus
this
how it
happens.
changes. Wait, and that's not what it is?
So, I still have to get snowden done. And the roads. And the cold, but aside from that.
Different loading bars up here.
I started on Snowden. When I started recording, it was hard. That was so intricate. It is so much fun sketching it out.
Now, again, I know that they don't ask the same exact questions every year. That would be great if they did. But all of these questions and skills usually get asked in one way or another. So you guys got about 10 more minutes till you're dismissed. So try to find another question or two at least that you could get right on the real AP exam that you missed on the mock exam. 1 or 2 questions doesn't sound like a lot, but when you only need like 45 points total to pass, that is going to be the difference for some people.
this isn't about speed, and this isn't about speed. Those are about velocity. Velocity and speed are the same thing. So I don't know if that's what your issue is, but it's going down because the velocity is negative at that time. Correct.
So I put increase in velocity.
It's speeding up to the left, but we would still say that velocity is decreasing, because if acceleration is negative, that means it's going faster to the left. And if it's going faster to the left, your velocity is getting more negative.
Okay,
So it's decreasing even more.
when it says velocity, we have to include direction, but when it says speed, it's just magnitude.
Yes, yes. Speed, making sure they have the same signs, is only if you're interested in if it's speeding up or slowing down. If it's referring to velocity, that's a whole different thing. Velocity is increasing if acceleration is positive, and velocity would be decreasing if acceleration is negative. Because you're only interested in if it's getting bigger over time or smaller. That one's kind of a tricky question, but.
Dr. Chris Dowry, what's the Jason's work medicine?
Was this, practice, so it's harder than you expected?
It's kind of easier. I didn't do great on it.
Like the funnel cake and stuff like that.
How's it easier and you still didn't do the work you did great?
Well, 'cause I thought I was gonna get like 0, but I got 25 out of it.
Hello? Hey. He is. Sure. Thanks. Bye. William, you need to go see Miss Lawson to get your graduation stuff.
Okay.
Do you know where her office is? Okay. Do you know where Dr. Miller's office is? Oh, no. Okay. You go in, like you're going to the basketball gym, you take a right to go down this hallway, and before you turn left, like it's got windows along your side, before you turn left, it'll be the office right before you turn left. Okay, thank you.
Okay, you guys have about 4 minutes, so you might want to finish up your thought. Again, the only thing I'm asking you to do for homework is please do the next part of the mock exam, 2 free responses. Even better if you have time to start studying for your AP exam, but at least do those 2 free responses, 30 minutes total, between now and Thursday, please.